So, good morning. I'm going to talk to you about Postgres XL. The X in Postgres XL has got nothing to do with Brexit, okay? So, no questions about that. So let me tell you about, gosh, this is like really loud. Can you hear me without it? Yeah, you take that and I'll just speak into this because that's super loud. Okay, so what I'm going to talk to you about today is Postgres XL, and I'm going to talk to you about this as a technology, okay? So I'm going to talk about things that it does, how fast it is, things like that. But the purpose of Postgres XL is to provide extra performance when it matters. So on the last slide, we had a picture of a data lake and we talked about business intelligence. That's what this is for, okay? So while I talk to you about it as a technology, it's really important that you understand why you would need this technology, okay? Because technology for no particular purpose is just worthless, right? So you have to have a business need that drives the use of a particular technology. So if you are in a position where your business requires large volumes of data and very important speed of access to business intelligence, then you've got a problem that this might solve, okay? If you don't have those things, this is just interesting technology, okay? So I want to get that clear in your mind that my interest in this technology is because of the business applications of it, not just because it's cool tech. And it is cool tech. So what is Postgres XL? Well, it's a faster, more scalable version of Postgres. Okay? So we've tried to keep as many things the same as Postgres, but ultimately the thing that we're trying to do is to make it more scalable, so we can have more data and faster results from that large data. Postgres XL is open source, so it's the only scalable version of Postgres that's got an open source license compatible with PostgreSQL itself, and that is obviously important as well. So what is the technology? Well, it's a massively parallel processing, or MPP, version of Postgres. That means that instead of the database running on one system, it means it runs on many systems. So we actually have multiple data nodes in the system rather than just one data node. And we also have some other nodes in there as well. We have things called coordinators, which do the SQL processing and planning, and then the data nodes themselves do the actual work. There's also something there called a global transaction manager, and the purpose of that component is to give a totally coherent view of all of the data in the database. And it's very important to understand that this provides an ACID database. This is not eventual consistency or anything like that. We're talking about exact semantics, so you get the exactly correct answer when you ask a query, no matter how many changes are being updated at that one time, okay? So exact ACID spread across multiple nodes. Now that is something that you will not see in the world of NoSQL. All of those solutions are all eventually consistent. This one is not. It has strict semantics, and that's very important, basically, in the world of transactions and correct results to your queries. So where did this technology come from? It's easy for me to tell you about some cool new technology, but obviously, if you don't appreciate where the technology has come from, then you might be persuaded that actually the technology isn't very deep, it's just a small thing we wrote one afternoon. Well, the technology here has been developed over many, many years, in fact, by a great number of people. So the product that I show to you today is not all the work of Second Quadrant. In fact, we've only been working on it for about 18 months. But what we have done is taken that technology and updated it to the latest production release, which is 9.5, and we're making sure that that product is mature. We're flushing out all of the bugs that were still in the old code and making it ready for use. So just to say, if we claim any credit for doing this recent work, we don't claim credit for all of the previous work that's been done over many years by a great number of people. The last work has actually been done sponsored by the European Union through a research project that I was coordinating called the XL project, which stands for Analytics on Extremely Large European Data. Obviously, with a name like that, we were able to get funding, and so that was good. We've put our efforts, we've used some of that funding to bring XL back to the latest release for people to use. And of course, I'll get the joke in as well. It's just as well this project's funded now, so possibly future ones won't be. So. Okay, so this is where I start to show you some numbers. What I'm going to do is show you some numbers that we had last year, and then give you some updates as to where we are on the current technology. So last year we ran some benchmarks, and we showed here that the tool lines are in blue is standard Postgres, and we benchmarked it against Postgres XL, which is shown in red. And as you can see, in almost all cases, Postgres XL was extremely fast in comparison with Postgres. Okay, so that was a 10 terabyte test, and we ran it on 16 nodes running on Amazon EC2. There were 22 queries in that mix, and on average, the queries were 6.4 times faster. What does an average mean? Well, not very much in this case, because the queries are all different. But the important thing to understand is that more than 50% of the queries showed linear scalability, and that is something that's very important, and I'll talk a bit more about that in a minute. One of the other things that we did was run some OLTP tests as well, so transaction processing tests. And the blue line at the bottom is Postgres, the red line is one node XL, and then we did 2 node and 4 node tests so that you could see exactly the performance that we were getting with varying numbers of nodes. Now, what this is showing is for simple OLTP workloads, the database scales naturally outwards. Now, I would stress that this is for simple OLTP, okay? So if you've got a workload that fits this criteria, then this will scale as well. So here we're showing 2 separate workloads, both of which naturally scale on Postgres XL. We've got OLTP, where we're able to add nodes and we're able to increase the number of transactions per second we can handle. Okay, the transactions don't get faster. What I'm talking about is we're adding capacity. Okay, now and the second mode is business intelligence, in that if we add nodes, we're able to make the queries faster. So 2 types of workload, both of which speeded up by Postgres XL. And just some details on the tests, just to mention that all of the queries that we ran were running with full ACID compliance. So there's no eventual consistency or weirdness going on, where you're getting the right answer to these queries every single time during the tests. So let me just say again what this linear scalability means. The tests I just showed you were running on a 16 server, 16 node as I call it, configuration. Now we've got performance tests that show that if you increase the number of nodes by a factor of 2, then the performance that you get will increase by a factor of 2. So if I go from 16 to 32 nodes, then my queries get twice as fast. If I increase to 64 nodes, then I would go 4 times as fast, okay? And this is what's known in the industry as linear scalability. This is a characteristic of massively parallel processing, or MPP systems, okay? This is real, okay? It's not make-believe. We can do the tests again and again, and they'll show the same result, okay? If you add nodes, it gets faster, okay? And that's because the workload spreads evenly across the nodes. Now, another way of looking at this is that if your data is growing over time, then you can keep the times of your queries constant just by expanding the number of nodes, so that you keep the amount of data per node constant. So as your data grows, you just add more and more and more nodes so that your workload will stay the same. So you can actually use this as a way not to speed things up, but to keep them the same as your database grows, okay? So those points are important to understand. So what I'll do now is show you the latest results of Postgres XL versus PostgreSQL 9.6 beta. Okay, so these results are from the last week, and you'll see that the blue numbers are Postgres XL and the red numbers are Postgres beta. And the detail is that we're beating, or Postgres XL is beating Postgres core on almost every single query. Now, your first question should be, right, but is it a fair test? Is it a comparison that has meaning? And what I would say is what we've done here is we've used a simple 16-node configuration, and we've compared that against a Postgres database running on an 8x large instance. Okay, so what we're doing is we're running 16 X large instances on AWS and comparing that against an 8x large running core Postgres, okay, which is something of a comparison. So some other information that we've gained is to actually look at the way that Postgres parallel query works in 9.6. So the first bar shows Postgres 9.6 without parallelism enabled. So this is executing TPCH query 1, which is a simple but CPU intensive aggregation. Now if we enable Postgres 9.6 to use 3 parallel threads, you'll see that it gets almost twice as fast by giving it 3 parallel threads. But we say, oh, well, yes, let's make it go even faster, okay? So what we do is we give it 11 parallel threads, and by using 11 parallel threads, it gets a little bit faster, okay? So you see the graph coming down. Now, in comparison, Postgres XL on 16 nodes has got the 4th bar, showing that the aggregation on Postgres XL is much better than the aggregation on core Postgres at the current time. The other thing to note is that core Postgres doesn't yet parallelize everything. By its very nature, Postgres XL parallelizes everything. Now, that doesn't take much code to achieve, because all we've done is we've chopped the database up into pieces and spread those pieces across multiple nodes, okay? So actually, by doing that, all of the code naturally runs faster. Now, what's happening in core Postgres is we're having to rewrite lots of operations to get them to work in parallel, and that hasn't happened yet for copy, for vacuum freeze, for create index, for adding a foreign key. And you can see the comparison times here. The red times are core Postgres, the blue ones are Postgres XL. So it's a lot faster on these utility actions. Now, if you imagine that your database is multiple terabytes in size, you can see the differences in these times would be quite dramatic, okay? So we're aiming at very large databases. What does very large mean? I'm really talking about if you've got data in excess of 1 terabyte, then I personally think Excel would be suitable at this point in time. So let's look at some other numbers. What I wanted to show you here is something where the cost of the systems that we're using is exactly the same in both cases, okay? So we've got exactly the same number of CPUs, exactly the same cost, exactly the same amount of SSD, and exactly the same amount of memory, and exactly the same amount of data on these two comparisons. And you'll see that in almost all cases, Excel is faster than core Postgres, okay? And that's quite a surprising result, because everybody's kind of expecting, well, it's like the same, isn't it? Why would it be different? Well, here's why it's different, because there's actually two different types of parallelism at work here. What core PostgreSQL has at the current time is what's called intranode parallel query. Intra meaning it executes queries on multiple CPUs within a single node, and that's intranode parallelism. What Excel gives you is extra node parallelism. It allows you to run actions spread across multiple data nodes. So the type of parallelism that it gives you is actually a much better way of spreading actions out across multiple nodes, and that's actually a much more scalable mechanism. And the other thing to note is that the times that I've shown you occupy different amounts of capacity on the machine, in the sense that if you run a query that uses 12 CPUs on one node, then those CPU can't also be used by somebody else at the same time, because the performance would drop away. So actually, if you want a system that's got multiple nodes and supports multiple users, then you need to have multiple nodes involved to give you the capacity to spread out. So what I'm trying to say at the moment is that core Postgres has parallel actions in 9.6, and it will get better over time, and Second Quadrant and other companies are making it better, okay? We are investing in both Excel and in parallelism in core Postgres, but the parallelism in core Postgres has a long way to go to get to the point where it's the same maturity as the parallelism in Excel, okay? We want to get there, but it's going to take a while, okay? And the way to explain that is that when we delivered streaming replication in 9.0, that was the basic feature. And as soon as you began to use it, you said, oh, it doesn't do this, and it doesn't do that, and it doesn't do this. And then 9.1 came along, and we fixed a ton of problems with it, okay? But it didn't fix everything. We still needed some additional things like cascading replication or timeline following and such things came in much later releases. And even in the latest 9.6 release, we're still fixing things like performance tuning problems, monitoring capabilities, such things. So it's really you can't deliver a big feature all in one release. It just doesn't work. So what I'm happy to say is that 9.6 delivers parallel query to you, but it doesn't yet deliver everything you will need in order to run large-scale business intelligence or data lakes on your Postgres systems. So it's good, but it's not fully there yet, okay? And what I'm saying to you is that Postgres XL has greater maturity now than Postgres Core, okay? And what I'm hoping is that over time, the two things will come together and we will eventually get rid of Postgres XL. We'll just have core Postgres, okay? So that's what we want to see. So in terms of what we have right now is Postgres XL is currently faster than PostgreSQL. It's more scalable because it's available on a massively parallel processing system. It's available now. It's available with the same license as PostgreSQL, and we believe that the technology in Excel can be used to feed into the future of core PostgreSQL. Okay. So in terms of where we are now, Postgres XL 9.5 has been the subject of approximately 18 months' work at this stage, bringing it up to maturity. We have spent almost a year now removing bugs and tuning it. So we've done quite a lot of tuning on it in the background. Release 1.1 was released in April, and there's going to be other releases in the future. So we're continuing to work on this. We do have international support. The core team of Postgres XL is not just second quadrant. We've got people from NTT, Hawaii, and the European Space Agency are all helping with the process of bringing this technology to the market or maturity. So in terms of Postgres XL, second quadrant is providing support for that, so it's usable now, and we're hoping to get piece by piece get this technology into Postgres Core. It's already been the subject of some debates as to exactly how we do that. Very, very clearly, it is not going to happen in one big sort of bolt-on action that we take all the differences and make them to core. That's just never going to happen, okay? But if you look at what's happening with, say, parallel aggregation in core Postgres does derive significantly from the way that Postgres XL works. Now, there were some moves to change the way that works. There's been some recent discussion by Tom Lane about, I don't like this and I don't like that, but we made the point that the way that it works is very specifically the best way in the long term, because we know we need multi-stage aggregation, not just two-stage aggregation, but multi-stage aggregation to allow the full performance benefits of massively parallel systems to come through. So Postgres XL is available now, and it works, and it's fast. So please, if I say give it a try, that's a kind of trivial thing. It's not like you can set it up in 5 minutes and get running on it. There's lots to do, but it is fully usable and available now. So, can I take questions? Marco.
be the strategy to back up such a huge amount of data?
So what we've done with Excel is, that was my first criticism of Excel, was in fact that it didn't have high availability. So the 9.2 version did not have any form of high availability or backup, which is, kind of, as you might imagine, kind of restrictive. So I've beaten the guys up and said this has to be highly available. So we've built high availability into it. And the backup is more complex, absolutely, definitely more complex, because you've got multiple nodes, but those facilities do now work with Excel.
You talked about terabytes database, but you also state that costs are similar for servers. So why it's not worth to take Postgres XL in consideration also for gigabytes database?
Well, I think you can if you want. I mean, obviously there are some situations where you've got a very high performance requirement, even though you've got a small amount of data. I think that can work. It's less... the more obvious positioning is, if it's more than a terabyte, then it's a good use case for Excel. Less than that, I grant you there are cases where Excel is good, but it requires more careful thought to make sure that you have the positioning correct. Plus, you must understand, I'm a strong advocate of core PostgreSQL. So I would not be in a position where I would say you must not use core PostgreSQL. Okay, so please understand, I support both. Yeah. So.
Excel?
So sorry, which features?
All those new features that have been introduced in newer versions of PostgreSQL.
In 9.6, do you mean?
Yes.
Yeah, I mean, what the Postgres XL technology was available at 9.2, and what we've done is updated that to 9.5. So what we wanted to do is make that technology available. I think what you're asking is, are there going to be later versions of Excel that have newer versions of 9.6? Yes, but we're still getting 9.5. We feel that we're still bringing that to maturity. So there's a number of possible futures for Excel. One is that we could move that onto 9.6. One is that we decouple it completely and just introduce it as some kind of extension on top of Postgres. Now those things are possible, but I don't want to comment at this point on, on what that roadmap is. There will be a roadmap, because my feeling is that Excel is, as I said, 3 to 5 years ahead of core Postgres, and obviously 3 to 5 years is quite a long time. And for people that have been watching the process deeply, of course, there will be people that say, well, 3 to 5, what that really means is 2, okay? And I'd say, look at logical decoding and how long that's taken to put into core, and you think how long it's going to take us to get massively parallel processing in core Postgres. Honestly, I think 3 to 5 might be a low estimate rather than a high estimate. Okay. So yes, there will be a roadmap, but we're not at that stage where we've started working on the next release and haven't yet decided what architecture that will be.
And one more question. If we just say that we run only queries that will get only one row, and the execution will be by using index, will there be any difference by using core PostgreSQL or Excel?
If you're accessing one row with an index?
Yes, and we just say, we know that in reality it's not like that, but we just say that the workload is that.
So the Excel system is a distributed system, so it takes at least 2 nodes to answer any query, okay? So there will always be a higher latency for your transactions in Excel as against core Postgres. But the important thing to understand is that the latency that you will get from Excel will stay constant as you expand the nodes. With core Postgres, the latency increases and increases as the database grows in size until it falls out of memory and it becomes very high. So the latency for core PostgreSQL will just go up like that, and then after a certain point it will go up even worse, okay? With Excel, it will be high to begin with, but stay constant, okay? So it is a different characteristic. What you have to understand is it's like the difference between going somewhere by car and flying somewhere in a plane, okay? The overhead of getting into a plane is high. You need to go to the airport, you need to go through customs, you need to do a lot of stuff, right? And so if your journey is only 50 miles, then this is a huge overhead to pay. If you're going 5,000 miles, then clearly the aeroplane wins, right? So there's a crossover between which technique is best depending on how far your journey is. So this is the important thing to understand. So Excel is not fast in its individual response time. It is scalable in terms of its ability to handle a workload with a constant useful time.
Thank you.
Were the tests only done with AWS nodes, or did you also have a hardware setup where you used a storage system? What I'm interested actually is the latency on the storage and the number of IOPS these different data nodes will generate. So
we wanted to do the tests in a way that would maximize our ability to do the tests, but also to present them in a way that was comparable so that people would believe and understand them. So that's why we used AWS, because it's more convenient to sort of specify configuration, run a test, and then shut it down again, okay? So we were able to do the tests quickly and cheaply. To get hardware configs in the various shapes that we would need could cost many tens of thousands if we spent our time with it. Obviously, if anybody's got some hardware for us to test on, we'd be very grateful. All of the tests here were done with SSD disks because we didn't want disk to become an issue in the tests. But obviously, if you've got very large data, you would be strongly inclined to have much larger non-SSD brown disks that would serve up IOs. And in that case, Excel gets much better, much quicker, because when you distribute the IO in a massively parallel way, Excel becomes quickly very, very good. So.
I also have a second question. Is it possible to do online upgrades with Excel?
Online upgrades, what we're planning to do is to make that possible with logical replication, but that doesn't fully work at this point, okay? So the way that the high availability works with Excel is that each node is protected by standard core streaming replication, and we can actually use that to run an upgrade on a per node basis and then roll across the whole config and restart. So it's not something that we've worked on yet, but we do believe it will be possible in the future to do that. And obviously it's a strong goal for us to be able to do that kind of thing. So.
Okay, thanks.
That's it.
Does Excel support extensions like the other Postgres? My first test is Postgres.
Yes, it supports Postgres. There are some actions that are not as easily possible. So, for example, you can't distribute a table using a GIS data type. You would need to use standard integer or character data types for your distribution key. But you can have various types of GIS data types in the rows of your database. Yeah, so that works. There are various other types of extension that work just the same. So in general, it's extremely similar to core Postgres.
Thank you.
One more question. Have you made some test about the speed also for PostGIS or not?
Is that the same question?
No, about the speed is the same.
Well, I mean, we haven't tested everything, so you know, what the tests that we've done are really just to sort of check that we're getting it right. Obviously, there's a whole range of tests that we could do. You know, our preference at this time is to test on real customer situations rather than just, you know, things in the lab, because what matters is whether it works for you.
Thank you.
Okay, thank you very much for all of your questions, and